Hello. Oh, where'd you go? Oh, there you are. Oh, I haven't done my hair yet. I'll wear the hat. There we go. We put a hat on. Hey guys, statistics. Thanks for watching. Woo, bye. Oh, I'm still here. Yeah. So basically, we've been learning how to do box and whiskers plot. We did the 5 number summary, which is your minimum, maximum, Q1, Q3, and the median. Your range, your interquartile range, which is talk about today, Q3 minus Q1, and then box plots, and then outlier rule. Nice. Then chapter 6 will be standard deviation, empirical rule, and z-scores. So we'll do another video course for you for those ones. So again, the 5 number summary is basically the minimum, the maximum, median in the middle, the Q1, which is the lower quartile, which is the 25th percentile. It's basically the lower median. And then the upper quartile is the 75th percentile, or the upper median. Cool. Interquartile range is Q3 minus Q1. And then to make a box plot, you use all 5 of those numbers, which you did in the last assignment. And then we'll discuss the outlier rule, which is for 5-2, the next assignment. Cool. Okay, so just a quick summary here of the 5 number summary. Let's say we have shoe size in women's and then men's. So basically in class, this is last year's data, we went ahead and collected people's shoe sizes. 7, 14, that's a big shoe. 8, 12.5, 12.5, 10, and 10.5. I think we converted it to men's as well, or something like that. Or the other way around. Okay, put the data in order from least to greatest. So step number 1 is collect your data. So let's go ahead and point that out. Step number 1, collect your data. Step number 2, put the data in order from least to greatest. So this is super important. So 7, 8, 10, 10.5, 12.5, 12.5, 14. So that's putting those numbers in order up here from least to greatest. Awesome. Okay. So then you can see here, I've already kind of done it, but let's talk about it. There we go. Okay, there we go. Okay, so then, first of all, we've got our 1, 2, 3, 4, 5, 6, 7 numbers. And so this is important because this, of course, is an odd set of data. Hope you guys are doing well at home. Thanks for watching. So this is an odd set of data. If I can get rid of this. Wow. What's going... There we go. Okay, so odd set of data. And so that means the median is not going to be 2 medians, just 1, right? If it was even, it'd be 2 medians. You'd have to average the 2. And so you could work your way into the middle, which is what we did here. Work our way into the middle. So we go 1, 2, 3. 1, 2, 3. So 10.5 is our median. And so that's the middle of our data. We're trying to come up with our 5 number summary right now. And this is for an odd set of data. And then, so our Q2, also known as the median. Okay, so next, step number 3 says that we want to identify, calculate the minimum, median, maximum. Well, we just did that. Here's the minimum, here's the maximum, lowest number, biggest number, median's in the middle. Okay, step number 4. Calculate the Q1 and the Q3, also known as the first quartile and the third quartile. So I did notice on some of your guys' assignments you're getting this wrong. So please pay attention to this lesson and try to get it right this time. You got this. So Q1, you calculate it by finding the middle number between the minimum and the number just to the left of the median. Okay, that's for Q1. So let's do that. So we want to find the middle number between the minimum and the number just to the left of the median. Okay, so here is the minimum, and then here's the median, and we actually want to go just to the left of the median. So we're going to go right here. Let's use a different colored pen so you can see this a bit better. So if this is the median, right, we're going to go to the number just to the left of the median, that's there, and start at the minimum here, and then we work our way into the number between those two numbers, the number just to the left of the median, and the number minimum, and then work your way in the middle. I think I tried to do something like that with this. Yep, there it is. There's your Q1. Awesome. So then your Q3 would be that one. Cool. So that is called our 5-number summary. Woo! You can also use it to make box plots or box and whisker plots. Cool. And then we're also going to use it to do the outlier rule and make modified box plots, which we'll show you here in a second. So this is an example of our box and whisker plot, right? So we have 7, we have 8, which is our Q1, and then 12.5 is our Q3. So we have 7, 8, 10.5, 12.5, 14. So there's our 5-number summary, and then there's how our box plot works. So the minimum is going to have a vertical bar here. Q1 is going to have a vertical bar. Median will have its own vertical bar. Q3 vertical bar, maximum vertical bar. And then we draw a TIE fighter. Woo, TIE fighter! And then we connect the top and make a middle box, right? And so this middle box is actually the middle 50% of our data. Didn't know if you already knew that. Each of these boxes represents 25%. So this is 25% of your data here. This is 25% of your data here. And then these two are 25 each. So that makes 25, 25, 25, 25, 100% of your data. Okay, this is also known as the IQR. That's called the interquartile range. And so that's basically this distance. It's just your box. That distance of your box. And how you find it is Q3 minus Q1. So watch this video again if you haven't taken notes yet. Take some notes and kind of learn how to find the IQR, interquartile range. We're going to need this for doing the outlier rule, making a modified box plot. Okay. And then of course the range is the whole distance, which is the maximum minus the minimum, which is going to be the whole distance. That's the range. And now you try. Woo! Okay, so now we're going to look at shoe size in men's for lots of women. Here we go. Okay, so now let's just kind of do a quick review here since we're just teaching you at home. And so we collected 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sure you're still recording. Yeah. So we have 12. Ooh, so this is going to be a bit different now, right? Because this is an even set of data. And so an even set of data is going to have 2 middle numbers, 2 medians, right? So first we have to put them in order from least to greatest, which it looks like looks like what we did already from least to greatest. Let's take a look. Oh, we didn't yet. So that's the first step. You got to put these in order from least to greatest. Nice, nice. Our minimum was 5.5. Our maximum was 13. Cool. So we'll put that down. Minimum 5.5. We're just kind of eyeballing it, but really you need to list them all in order from least to greatest. And then it turns out the 2 middle numbers will be 8.5 and 11. And so when you work your way into the middle, how do you know what the middle is? Well, there's 12 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 numbers, and so to find it, we divide by 2 because it's even, so we get the 6th and the 7th position. So you add one more. 12 divided by 2 is 6, plus one more is 7. And so if we'd put these all in order from least to greatest, which I don't think it's going to let me, because, yeah, it's all connected, sorry about that. But if you did that, indeed, you would get that the 8.5 would be here, in this position, and the 11 would be here. And so that'd be the 6th and 7th position, and so you have to average them together. Add them together, divide by 2. That's going to give us a median. And then from our median then, we would use this number, this position, and the minimum, and then we would work our way. So you have to do left. If the median's here, you'd have to go left to the median, which would be this one. And then you work your way in to the middle. Oh man, we have to add them together, divide by 2 again. So these two positions you'd add together, divide by 2. We'll do that in a second to help you get ready for your homework here. Okay, let's see here. Don't forget to make your TIE fighter. That's what I was going to do. I was going to draw a TIE fighter, and I was going to put like Darth Vader inside. TIE fighter. Awesome. So this is kind of our lesson I was going to do in class, but obviously we're not there right now. Okay. So then let's just go ahead and work together at home. So 5-number summary of the even set of numbers. How many slices of pizza can you eat? So this is from last year's data here. And so we're going to go ahead and show you. So step number 2 is to put them in order from least to greatest. And so if we do that, we go ahead and get 3, 4. Whoa, what the? Sorry, there we go. Cleaning it up. Okay, so there we go. Not really cleaning it up, but you know. Okay, so step number 2, put them in order. So 3, 4, 5, 6, 6, 6. Don't be superstitious. 8, and then 24. Awesome. Okay, so then it says, please find the 5-number summary for the data pertaining to the number of slices of pizza a person can eat. Cool, so we did it. There we go. Who could eat 24? Come on, who is that? I don't remember, but he ate a lot of pizza last year. Okay, awesome. Okay, so then to find the 5-number summary again, and then we're going to get ready for the outlier rule, actually, maybe. So then we do, let's see, so that's the minimum, that's the maximum, right? The highest and lowest, minimum and maximum. Awesome. Awesome. Okay, so then to find we count 1, 2, 3, 4, 5, 6, 7, 8. So is that even or odd? That's right, it's an even set of data. Since it's an even set of data, how many medians do we have? 2. And this is actually really important when you're trying to find Q1 and Q3, right? Because we're not going to use the median, we're going to use the number just to the left and just to the right of the median. So when we work our way into the middle, we do get 6. And so our median is actually right here. Not the red numbers, it's actually this blue number. That's the median. And the reason why is because it's even and you have to add them together and divide by 2. And 6 plus 6 is 12, divided by 2. 12 divided by 2 is 6. So now to find Q1 and Q3. What the? Newbold, they're not in order. Oh, sorry, just pretend I did it down here. Okay, so we added those together, divide by 2, we got 6. Wrong one, Newbold. Sorry. It does matter. It does matter. Position matters. Be careful. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. So this is definitely the middle. Okay, so again, now how to find Q1 and Q3. And then my next video will show you how to do the modified box plot part. Okay, so then this is the minimum is not 5. Maximum is 24. The minimum is actually 3. There we go. Okay, so then we want to find Q1 and Q3. So then we could do the interquartile range, you could do outlier rule, do a modified box plot. Okay, so then we actually start to the number just to the left of the median. So if this is the median, we start to the number just to the left of the median and the minimum, and then we work our way into the middle. Okay, so we have 2 middle numbers, so we're going to have to add them together and divide by 2. So 4 plus 5 is 9. 9 divided by 2 is 9 halves, or 4.5. So that's going to be our Q1. Then we do the same process, but we go to the number just to the right of the median now. Just a coincidence that the median and these two numbers are all 6s. Doesn't always happen, of course. Yep. Okay, so now we go and we work our way into the upper middle. So we're going to add those together, divide by 2. 6 plus 8 is 14. And divided by 2 is 7. So Q3 is our 7. So we go 3, 4.5, 6, Hey, look, we did it right. 4.5, 6, 7, 24. Nice. Okay, so now can you tell me what the interquartile range is? So again, remember the interquartile range is Q3 going this direction minus Q1. So Q3 is 7 minus Q1 is 4.5 is 2.5. And so that is the interquartile range. Awesome possum. Okay, so now this is going to be something new called the outlier rule. Okay, we'll go into more detail in the next video about what the outlier rule is, like, you know, with notes, so you can write it down specifically, all the good details. And so just to give you a hint of what to look forward to. Oh, maybe not. Oh, what the? That's interesting. Oh, here it is. Okay, so Mr. Newbold's favorite, the outlier rule. So our next video, we'll do this together just to have you practice and learn some more with me. But right now, we'll just kind of give it to you in a nutshell. And for those of you that feel confident, this will be everything that you need for the assignment. But I'll definitely watch the second video. Okay, so for the outlier rule, we're trying to come up with a lower boundary, right? And an upper boundary. And anything to the right of the upper boundary are going to be outliers. And then anything to the left of the lower boundary are going to also be outliers. So let's go ahead and demonstrate this. Now remember, these upper and lower boundaries that we're trying to create, so they are not a part of your data. They are just boundaries to help you find outliers. Nice. So just kind of wanted to throw that out there, that they're boundaries, they're not actually the data. Cool, so don't forget that part. Awesome. Okay, so now here's our outlier rule, okay? So we're going to take Q1, which was 4.5, and we're going to minus it, so Q1 minus the IQR times 1.5. 1.5 is just a general statistics. You could use 2, you could use 1, you could use 4, but in our class, we're just going to use 1.5 because that's just the general rule. Just to go 1.5 times bigger than your interquartile range, right? So if this distance here is your interquartile range, we're going to go 1.5 times bigger than that, so that will make it just a little bit bigger, and then see if we have outliers or not. Okay, so the interquartile range that we figured out is 7 minus 4.5 is 2.5. And so then that goes here. Here's our 2.5. We're going to times it, make it 1.5 times bigger, and that gives us 3.75. And now we're going to take our Q1 4.5, and we're going to minus 3.75, and we're going to get an LB. What's up, LB? We're going to get a lower boundary of 0.75. Right, LB stands for lower boundary. And then we're going to take Q3, which in our problem, our upper quartile we figured out was 7. Remember? It was 7. We figured out what Q3 was. Now I can't circle with this mouse very well. Okay, so then what we're going to do is we're going to take that lower boundary. Now we're going to take Q3, which is 7, and we're going to add that same IQR. 2.5 is our IQR. Times 1.5, and we're going to get 3.75 again, but this time we're going to add it. So 7 plus 3.75. And this is called our upper boundary. Upper boundary. And so this is our upper boundary. Awesome. Upper boundary. Okay, so that's our upper boundary. And so now we're going to use our lower boundary as well as our upper boundary and see if we have any outliers with our data. And then we'll graph a modified box plot, show you that in a second. And then we'll go over it again in our next video with and kind of give you hints for the homework assignment. Okay, so definitely watch both videos. Okay, so what is our lower boundary? So our lower boundary is 0.75, not even 1. It's 0.75. So if we're going to graph this, 0.75 would be right here. Okay, that's going to be our lower boundary, or LB. Lower boundary. So anything to the left of that now, to the left, L-E-F-T, anything to the left of that is going to be considered outliers. And so on this side, our minimum was 3, which is not to the left of 0.75, so no outliers, no lower boundary outliers, none, no outliers there. Awesome. I don't know why it didn't let me grab that. Oh, it lets me spin it around. Cool. Okay, no outliers there. But our upper boundary is 10.75. And so 10.75 is actually going to be right here. And so that's basically saying that, again, that's our upper boundary. So that's basically saying that anybody that can eat more than 10 3/4 of pizzas, 10 slices of pizza and 3/4 of a slice, almost 11. Anything above that, they are definitely outliers, right? That's like too many slices. That's impossible. Guinness Book of World Records. Oh, you can? That's amazing. You're so good at eating pizza, pig. No, just kidding. I can get close. I think I've got up to 13. I don't know. Okay, so I'm in the outlier range too, just like you. So that means that our maximum, which is 24 slices of pizza that someone said they ate last year, that's actually now going to be an outlier. Okay, an outlier instead of a maximum. And the number just left of it will become the new maximum. So in this case, our new maximum, so in this case, that's also going to be our Q3, which is crazy, right? It's going to be two things. It's going to be a new maximum, and it's going to be a Q3. Well, what does this even look like? Okay, so modified box plot. So this is our regular box plot, right? We got 3, 4.5, 6, 7, and 24. That was our 5-number summary. So if we graphed it, it would look like this. And then our modified box plot would look like this, right? So there would be the 7, which I'm off here now. Oh wait, is 8 a number on our data? Ooh, so it's not going to be 7 necessarily. No. So our new maximum is just the number just to the left. So our new max is the number in our data set just to the left or right, just next to the outlier. Does that make sense? No? Let's think about it. Okay, so our new maximum is the number in our data set just next to our outlier. So if our outlier is 24, I thought it was going to be 7 as our new maximum. But if we go to our data set, it's actually not 7, it's actually 8, right? Actually 8 is in our data set. And 7 was our Q3, but it wasn't even in our data set. So 8 is going to be our data set. So 8 then is going to be our new maximum. And then you want to denote the outlier with a star. So denote our outlier as a star. So now we go down here to our modified box plots, and 24 slices of pizza is an outlier. Here's our star. And then we go all the way down to 8, which is our new maximum, and then our minimum, and this is our Q1 and our Q3. And that's how you do a modified box plot. Cool. So you're going to need to know how to do that on the homework. We'll come back and do another video, give you hints. So definitely, thanks for watching. And watch the next video too. Thanks for watching. Peace out. Bye for now.